Hello, for those of you watching, my name is Alessandra Farmer, and I'm currently working in a lab at UCLA under Hugh Blair, and we are exploring the role of the amygdala in aversive decision-making using rats. So the amygdala is a region of the brain in each cerebral hemisphere that is commonly associated with the fight or flight response in mammals, which is the physiological reaction to a scary situation. Also, evidence has indicated that amygdala neurons can rapidly and permanently store memories during fear conditioning tasks, which is the reason that I can remember something that scared me, and I'm going to be more likely to avoid something similar in the future. However, despite the intense focus on the amygdala's role in fear learning, few researchers have studied its role in aversive decision-making, so our research will use Long Evans rats to explore the functioning of the amygdala. Here is a diagram of the human brain compared to that of a rat. As you can see, they are pretty similar, have many of the same parts. Here is the amygdala in the rat, and here's the amygdala in the human. So, data is collected from adult male and female rats. The rats run on this steel dual-choice rectangular maze, which has 2 reward locations in the upper corners. So, there are 2 different experiments. The first experiment, we are going to inject them with a virus, both the control and experimental group. However, the experimental group will have the actual virus that will aid in turning off the amygdala, while the control group has a virus that won't affect the rat, but we want to make sure that the rats have both gone through similar experiments, which is why we inject both of them. So then days later, we will handle the rat. We will get it used to being touched by humans, so that when we place it on the maze and take it out of its cage, it's not going to freak out. It's used to being touched and knows that it won't be harmed in the process when a human picks it up. So that was interesting for me because I did learn how to handle a rat properly and sit with it. You have to sit with it in the dark for like 15 minutes. It was interesting for me, but I did it. And then we place the rat on the maze. Both the control and experimental groups will go through the maze. So there is a short path, as we can see here, and a long path. So the rats can choose which one to take. However, if they take the short path, since the experiment is timed, they will end up getting more food because they're going a shorter way, whereas the long path, they'll end up getting less food. So after many repeated trials of this, the rat will start to learn to take the short path and will begin taking the short path every single time, whether it's had the virus to turn off the amygdala or not, because there's no fear involved in this experiment. So that experiment proves to us that the rat has learned that the short path is more beneficial to it. And then we do experiment number 2, which is where we involve a shock. And we can tell rats are scared because they freeze. So we can see that when they're shocked, they freeze. They're scared of that shock. They don't want to go back to that shock. And we have the control and experimental groups go through the maze. However, there's a shock zone solely in the short path. So if your amygdala is working, as we discussed earlier, that the amygdala neurons can restore memories during fear conditioning tasks, if your amygdala is working, you would remember that the short path is scary, you remember the shock, and you will begin to take the long path because you remember that fear. You don't want to go back there, you don't want to get shocked again. However, ideally, if our virus worked, the experimental group in experiment number 2 would continue to take the short path because the amygdala had been turned off, and it would not remember that it was scared, and it would continue taking the short path because it remembers that it is beneficial, it got more food, but it will not remember that it was afraid if the amygdala is not working. So that was our experiment. And our results actually suggested that the virus turning off the amygdala only partially worked. It is not as effective as the traditional method of lesioning, and the lesioning is actually just the removal of the amygdala from the rat's brain. We chose to do the viral method and are continuing to try to learn how to do it better because we did not want to permanently damage the rats, which lesioning does. In this experiment, since we had inactivated the amygdala of the experimental rats on the shock day, we would have expected them to run more short laps compared to the control group. However, we see the opposite effect, which goes against our hypothesis. This could be due to errors in the viral injection surgery, but other causes are also possible. Therefore, hopefully more experiments can be done in the future to figure out how to make the virus method work better. Thank you for watching this video. I really had fun in this lab. It was interesting to get some hands-on lab. I really enjoyed participating in this lab and honors research. I gained a lot of hands-on lab experience, which was good for me, and it was very fun. And I never thought I would be able to handle a rat, but I can.